Hello, everyone, and welcome to the CoROM podcast. This is where academic medicine meets remote, austere, and resource-limited areas. Welcome back to the program. This is Avergo Kelly. This week, we are again giving you, the listener, another presentation that we had during our Medicine in the Mediterranean conference last January. Vish Rajan is one of our remote paramedic faculty. He runs the third year of our bachelor's program. He is a retired commander from the Indian Navy and a diving instructor. He will discuss diving emergencies.
Good morning, everybody. I'm here to talk on hyperbaric misadventures or hyperbaric accidents. And for those of you all who do not know what hyperbarics is, has anybody been diving? How many divers here? That's awesome. So almost all of you all know what hyperbarics is. How many of you all have been in a chamber? Excellent. Those of you all who haven't been in a chamber, how did you all get to Malta? Did you all fly? Every commercial aircraft is a hyperbaric chamber, because you're going to be pressurized greater than the pressure outside in the environment. So this is me. I do a fair bit of stuff. I have done a fair bit of stuff. We'll not go too much into it. Not too many disclosures, excepting that I own a dive shop and I have a fair bit of endorsements for certain dive companies, and I teach at CoROM. So to start off with, I would like you all to think about the fact that most regulations, if not all, are written in blood, and primarily because you have accidents that people realize that there are problems and then go on into writing it into a regulation or a standard operating procedure. Hyperbaric misadventures, we had an accident yesterday in the US where a 5-year-old child died in Michigan in a fire and explosion in the chamber. We do not know yet why the child was being dived, and we do not know what table it was, but we do think that it is probably an off-label indication for the diving. We all know about Apollo 1, where the spacecraft chamber was pressurized and caught fire. If not, I'm going to cover it in one of my studies. And we have Tato's birthday, 49th birthday would have been 2 days ago. And unfortunately, he passed away in a chamber, which is a very unfortunate incident. Again, I'll talk about it as we go ahead. So my objectives are going to be talking to you all about a little bit of history of hyperbarics, which I know is going to be extra because almost all of you all understand it, but still we'll talk about a little bit about it. Approved indications for hyperbaric oxygen therapy. And I want to draw parallels here between how you have a formal indication and how you have informal indications and why people use them. Different types of chambers, and we'll talk about certain key accidents just to get an idea of what accidents can occur. We'll do a little bit of analysis, primarily talk about what has already been spoken about, human factors and stuff like that, and some recommendations. So the first known hyperbaric research was done by Robert Boyle, and he used an exhaustion chamber, or basically a vacuum chamber. He experimented on birds, but he first found it in a viper in a chamber, and he found a bubble that formed up in the viper's eye. And that's an exact quote from his article on it. Reverend Henshaw in the UK, who was using a bellows for various kind of treatments as to increase the pressure, but it wasn't that much over atmospheric pressure. So he was the first person who used hyperbaric medicine, so to say, well before Robert Boyle started or talked about Boyle's law and any other thing. This is the drawing of Boyle's chamber, if you all have seen it, and the one on top, the circle on top, is the evacuation chamber. Now, Paul Burt, we've heard about Paul Burt. Everybody knows about oxygen toxicity. So Paul Burt was the scientist who spoke about and talked about oxygen toxicity. Jacques Trigger, now, he is an engineer who built the first caissons. And it's an interesting story that he was a geologist whose fiancée left him, and then he went into rock bottom, basically devising methods to mine rock from over waterlogged soil. Things make us do stuff. Just think about all that. And Sir Moir was the first person who built the first medical lock, again for caissons, for the sandhogs. And this was the first time they actually thought about the bends and decompression sickness, was when the Brooklyn Bridge was being built and the Milwaukee tunnels. So he built the medical lock and decided to treat people before they came up to the surface. I don't think any lecture on hyperbarics or talk on hyperbarics should miss the goat in the chamber, because most of our tables have been made on goats by this gentleman, Dr. John Scott Haldane, who bent himself, put himself, his son, lots of goats, some sheep, I think, in chambers to develop some of the tables that we've been using. Now, this was Dr. Borema. I'm sure I'm killing certain names, but he did the first hyperbaric surgery, cardiac surgery on children in a hyperbaric chamber. This was before the ECMO machines came in. And the idea was that higher partial pressures of oxygen are now oxygenating tissue much better because you're dissolving oxygen and diffusing oxygen into plasma. So the concept was that you could oxygenate tissue better in a chamber and conduct surgery. He did this in the 1960s before the ECMO machines came in, and once the ECMO machines came in, it was history. Dr. Kindall is the first person who developed for therapeutic hyperbaric oxygen, which is non-diving related hyperbaric oxygen, so wound care and other indications. Just moving on, approved indications. These are the approved indications by the Undersea and Hyperbaric Medical Society. And I'd like you to read through this quickly and just see the language used. It's very medical, very professional, and is a fair bit of indications. And this is the one which the FDA approves, and you see the language and the tone is slightly different. And why I like to bring this out is because there are a lot of, I would say, physicians, but a lot of clinicians who have a fair bit of medical knowledge, but not too much on diving medicine or hyperbaric medicine. And they are using this language for treatment. And a lot of off-label, you've heard of oxygen bars. How many of you have been to an oxygen bar? Yeah, so they give you pure oxygen. So we'll talk about chambers now. And we have 3 different classes of chambers. And they're basically multi-person, which is a class A chamber. This is a monoplace, single-person chamber. Now you see this has a single lock. That means the patient goes in one side and comes out from the same side. There's no other mechanism or window to give the patient any medication or send in anybody else as an attendant. This is a monoplace, multi-lock chamber or dual-lock chamber, which has a medical lock. So at the back, that's the main chamber where at this point me and Dr. Curtis are. And so you would lock that part with this door and have the front portion here open, which would be pressurized at atmospheric level. In case you needed to pass any medication or get anything from the chamber, you would equalize the pressure from the main chamber into this. So both of them would be at the same depth. And then you would have somebody go in, pick it up and come out. I may be not explaining it properly, but it's pretty simple. And these are class C, which are animal chambers. It's used for, hyperbaric medicine is being used for horses a lot. There was an incident, which I'm not covering this time, but there was an incident where a horse kicked the chamber and they didn't remove the shoe, and that caused a spark and caused an explosion of the chamber. So we also have aerospace chambers, and Howard, this is the one which you were in just now. So these are hypobaric chambers where you are exposed to hypoxia. And for Howard, you want to talk about it? Why I brought this up also is, even though it's not hyperbaric, the fact that if you are in that chamber and there's an explosive decompression, you are going to be needed to be recompressed in a regular chamber. So they should have a safety chamber on hand for the purposes of the decompression. So we're going to review some key accidents now. And I will start with Apollo 1, which was the first well-known accident. So the crew had concerns over the quality of the chamber, the amount of flammable material, and generally, from what I was reading, one of the astronauts was not feeling too happy about the way he was feeling that day, just that premonition which comes in. So the changes which the crew had requested were not completed prior to the test. The crew had misgivings. Now, in this particular chamber, it was pressurized completely with pure oxygen to 2 psi over atmospheric pressure. Now, this is interesting because you could have pressurized it at air and kept the chamber pressure the oxygen percentage lower, and had them breathing on pure oxygen on a bib. Now, the cabin caught fire during trials, and that led to a sudden increase in the pressure inside the chamber. Now, with that increase in chamber pressure, the door that was supposed to be opened, the hatch to escape, was now no longer operable, because the door was supposed to open inwards. Now, with a higher pressure inside, you couldn't open the chamber. The hatch was also supposed to open 90 seconds. Now, the original design of the hatch took 90 seconds, so 1.5 minutes for it to be opened regularly without any complication. Now, imagine you're sitting in, like, say, the 3 of you all, even more cramped, and you have a fire around you, and you now have to operate a door which opens in 90 seconds. How long can you last? So, pretty much impossible to open the hatch. So, this was the report. These are the reports which came up. There was an ignition source, probably related to vulnerable wiring carrying spacecraft power. Now, they had a problem with the environmental control cabling and the source. There was some leakage that they found, but it wasn't, they thought that there was a leakage, but they didn't find a leakage when they did the tests. So it was one of the things which was left incomplete from the trial. It was a pure oxygen temperature, pure oxygen environment. And like I said before, they could have done it on air, but decided to do it on pure oxygen. And now this, again, highlights something which probably Dr. Daniel talked about, the human factors, where you have a pressure on the organization to deliver something, the pressure on people to do something, and that leads to certain accidents. To be fair, if you think about astronauts and people sending people to space, they're probably some of the smartest, most ingenious, not just clever, but they understand how to make do with less and make more out of less. So these are things where there are sometimes shortcuts happen. You try to do more without having the right resources. Even though you might have resources, you just don't want to do it. So, like I said earlier, the cabin was sealed, and this caused a lot of issues from the perspective that even the crew outside couldn't come and open them out because of the pressure. The flammable materials we've already covered earlier. They had a problem with the suits. They had a problem with nylon and Velcro across the cabling and piping in the compartment. If you think about the fact that it took 90 seconds to open the chamber normally, they were not prepared. They did not have an emergency decompression or a safety valve that could have lifted. Those of you who have been in chambers understand that there is a safety valve. There is a maximum pressure and there is a safety valve that goes off. Fun story, we did an experimental dive on a new chamber once, and we were trying to take it to 90 meters. We didn't realize that it was only rated to 70, and the valve went off at 65. While we were inside, we didn't really bother much because we were like, it's whatever happens now. We can't do anything about it. But the operator outside, he started pumping more gas in, thinking that it will stabilize. And it kept on going off till the time somebody came up and told them that there is a valve issue. The safety valve has gone off at 65. So again, human factors, we just messed up. So in this situation, all 3 astronauts died. They died not of the fire, they did not get burnt, but they died of asphyxiation from the toxic fumes within a few seconds. There's a couple of recordings out there if anybody wants to hear the morbid recordings. Now, this prompted a lot of design changes inside, and it also highlighted quite a few lacunae in the whole procedures and situation around how the design was, how the procedures, the SOPs, and the feedback mechanism between the astronaut class, the people training them, the designers, and as well as the national and NASA hierarchy. So this obviously led to what you call better interdepartmental communication. Now, when you look at interdepartmental communication, when you're an organization as big as NASA or any other large-scale organization trying to send people to space or do really international stuff, you realize that it's really key to have small steps and maybe take what you call a step back and reassess before you do anything. So I would suggest that we look back at all of us and all our departments and think about how we process and reprocess information in our communication. The next one is a little bit more interesting because it's more of a chamber-related misadventure. This was in Hanover. There were about 19 patients that day in a multiplace dual-lock chamber. And this is the chamber. So those of you who have been in a chamber before or have seen chambers, does this look like a chamber to you? Or does it look like more of a sofa set? So you can see there's a large amount of material that shouldn't have been there. The door over there, if you can see, that's a sliding door. It's not a hinge door. And you can see the evening dress that they're wearing while they're in the chamber. In case you all don't know, when you're in a chamber, it's a high oxygen environment, or even if it's pressurized on air, the partial pressure of oxygen is higher. You're probably breathing pure oxygen through the bibs, and that will probably leak at some point. And you can have a higher oxygen percentage even despite being in air. So any clothing you wear has to be non-static, so ideally cotton, simple cloth. Patients and the chamber should be grounded so you don't get any static spark. There are obviously no flammable materials. There is a change in batteries and certain other electrical equipment can be taken in. Shielded cabling happens. You do have large-scale machines nowadays which are well shielded and can be used for hyperbaric chambers. So this one is completely not how it should be. However, this was not a fire. This is the first known case of hyperbaric treatment fatalities. So people were being compressed in this chamber for a variety of diseases. The average age was between 65 to 78, and it was off-label, on air. There was no oxygen. We had 5 fatalities totally in this. So patients were compressed on air 30 meters, 99 feet for 1 week, and then the next week they were compressed to 40 meters for the next duration. Now there was no real table that was being followed. There was no oxygen available, and as you can see, because of the sliding door, the patient could not open the door from inside if they needed to. They were stuck inside. There was no chamber attendant. That's again, if you have so many people in the chamber, you want to have an attendant. Unless it's a monoplace chamber, you always want to dive somebody with them. So this was their profile. Those of you all who have dived, can you all see, do you all think that this is a non-aggressive table? If you all go and look into any decompression table or software, you'll realize that this is an extremely aggressive table. This is barely the amount of decompression that you would need, just about a few minutes more than the actual decompression required, and similar for this one. And these are all on air, so I wouldn't advise anybody doing this dive. I wouldn't dive this. Now on the day of the incident, we had this schedule, and there were 19 people in the chamber at that point, out of a total of 20. As they were diving, after the first dive, they were brought up. At about 9 meters, the first patients showed sign of decompression sickness. They did not stop. In a normal situation, when you're in a chamber and you have a patient who has a problem, you stop, assess, go back down to where the patient symptoms resolve. What they did was they went back up and then descended down to 40 meters, which is way beyond what they were at initially. And again, bear in mind, this is all on air. So you've already had a yo-yo profile. You've already had a patient have a problem. They went further down and the patient's condition improved. Now what they didn't do was wait for some time and gradually come up. They started to come up and the patient relapsed, which would have been pretty obvious. And instead of doing anything else, the owner came up and opened the chamber and had an explosive decompression or a rapid decompression to 9 meters. They then completed the decompression or whatever decompression was left, ascended up. Now what happened was they took the first patient down back again and they told the rest of the 18 patients. So I'm going ahead, but this is what. So we had 18 patients were told to go back home, saying that they had done enough decompression for the next week as well. Because they normally did 30 meters and then went to 40 meters the next week. Because they had done 40 meters this week, they were told to go home. Now while they were going home, a second patient collapsed in the lobby. The first patient was recompressed with a novice attendant who had never been in a chamber before. And while they were compressing this patient and the attendant had a block and they resurfaced the chamber again. So think about how many yo-yos the patient has already done. At this point, they did the smart thing of taking the second patient and putting them in the chamber. The second patient who had collapsed in the lobby. The rest of them are still on their way home. And this was the table they then followed, which is an extremely long table. It's an US Navy air table. But they did have a problem where they had an electric failure. They did continue, but by the time the 2 patients were already dead and the attendant was able to come back safely. Now what happened to the rest of the patients? There was no oxygen in the chamber. There was no oxygen available for the patients elsewhere. On the way, 1 patient collapsed on his bicycle and passed away, was taken to hospital and passed away. 1 patient was taken back to the hospital once they reached home and collapsed. And the 5th patient was taken to the hospital in the evening where they died next day. What happened was the hospitals which were receiving these patients called up the chamber and asked for any history about the patients. And they said there's no history, nothing's wrong with the patients or the chamber. They did not give any history about what was happening, that there was no attendant, there was no oxygen available, and that there was no training for any of the attendees in the chamber. The owner of the chamber was also not qualified on hyperbaric medicine. So as you can see, this is completely gross negligence. What happened at the end was this chamber got shut down eventually, and it's lying now in a museum. So what did we have overall from this whole incident? Completely gross negligence on the part of the chamber. They had no information available to anybody. They did not want to share any information. And the fact that they did not have an attendant in the chamber completely indicates that they had no reason to be running that chamber. The 11 patients who survived, the 13 patients who survived, they were picked up by the hospitals later on once they realized that there was a problem. Once they called up and figured out that these 5 patients who had passed away were actually in a chamber along with the rest of the people, all of the other patients were picked up and treated successfully. How many of you all have heard about this? How many of you all work offshore? You all have heard about this? So this was one of the worst offshore diving incidents in the 80s. It was an oil rig in the North Sea and it had 5 fatalities again. Now this was a deck decompression chamber on the rig platform. This had a complete fatality for 5 people immediately, and the 6th person was severely. Now, when we look at the factors for this, we'll talk about a little bit about what could have been done and what went wrong. But primarily now, if you look at this was the image of the chamber. Now, it was a bell that was connected to the deck chamber. Now, this chamber on top, the capsule-shaped device was the chamber. You had chamber 1, chamber 2, and this was the bathroom and the other lock. This was where the bell mated with the primary chamber and had a clasp here. Now, better diagram. Tender 1, tender 2 are outside the chamber, and you had 4 divers inside. So the normal procedure was that you would close the bell door, which is right here. You would then increase the pressure to close the bell door. So now the bell is pressurized and the door is closed. You would then close this door, which is the compartment between the 2 chambers, the trunk. Equalize the trunk and then open this clamp. So now both these systems are 2 independent chambers that have been pressurized, and this trunk is at atmospheric pressure, so you can open the clamps. This would be the normal procedure. However, the tender opened the clamp after step 2, so at the bell pressure. Chamber pressure was 10 atmospheres or 9 atmospheres, if I'm not wrong. And we had an explosive decompression from depth. So anybody queasy about images? So these are the positions that the 3 divers who were in bed passed away. As you can see, there's not much physical evidence of any injury to them. What happened also during the postmortem was noticed that they had fat emboli. So what they expect is that the bubbles cause denaturing of the blood to cause fat emboli. These are images from the postmortem. Diver 4 was the one who was at the door, and this is Diver 4's body. So he was pulled through the door, which was partly open, and had a complete, imagine going through a meat grinder situation. So the chamber door is really small. It was cracked open. The pressure was from 9 atmosphere to 1 atmosphere, sudden decompression. He was just pulled through and he was ground. So the problem with this was that it was an older chamber. The clamp, instead of having a regular door where you open a hinge, it had a clamp. Like how many of you all have seen a SIR clamp? Like a C clamp that fits on things. So it was like that kind of a design which had a large clamp and you just clipped it together and joined it. So not the nicest thing to happen, especially if you're come back from a long dive. These were 16-hour working days. So imagine you've come back from a dive, lying in bed. Somebody's going to close the door just before you go back to bed and you get pulled out. The company was pushing stuff on people. They wanted work to be done. It was a high-cost mission. And there is a sort of thought process that helium had caused communication issues. Now, when you're diving at that depth, you want to use helium for multiple reasons, it being less dense, it being lighter, and also because you can't use nitrogen and oxygen too much at that depth because it will cause toxicity and narcosis. So eventually it was attributed to human error. The company blamed it on the tender. Eventually, Byford Dolphin had a few other accidents and was decommissioned. But it did continue working even after this incident. Ocean Medical Center, Florida. This was a single monoplace chamber. Again, I'm highlighting this particular incident. There are quite a few incidents which I've not highlighted, but this one is of importance because of it involved a child, and we had a fatality yesterday of a child in a chamber. This is an older Vickers chamber, which is a monoplace, which looks like this. It's a clamshell chamber. You don't use clamshell chambers anymore. This chamber would open up and you would put the patient in, so like a clam. Now, there were 2 fatalities, the child and his grandmother. The primary reason for this was attributable to poor maintenance. The attendant was missing from the chamber and the area. Now, this is a monoplace, so you obviously cannot have an attendant with you, but the attendant and the operator who was running it walked away, left the person inside, and there were no emergency procedures. So this is how it looks when it's open. It shouldn't be burnt like this, obviously. And if you see, I'm not sure whether you can see this. I've got zoomed in images for that later. But you see this fixture over here, the controls, and you see them here. It's poorly maintained, badly fixed, tape over connections. So this is an obsolete chamber system. Again, if you understand and think about the chambers we've been talking about, primarily there have been issues with using old chambers, obsolete systems, poor maintenance, excessive working hours, all pointing towards human factors. Now, not only did they not repair damaged equipment, as you can see, they just put tape over stuff. This company fabricated a third-party company. They developed their own company and they put their own sticker over there, as you can see here, and falsified that the equipment was maintained. So they were shut down eventually. Now, I already spoke about grounding the chamber, making sure that the chamber and the patient are properly dressed. This chamber wasn't grounded. They did not have the patient grounded. And we for sure know that the child wasn't wearing the right garments. It was a crowded and dirty environment. And if you go to their website right now, it still has images of chambers. They're now the new monoplace chambers. And there are some older chambers as well in the images on their website. The website says that they've been closed since COVID-19. This incident occurred in 2012. So they were still open until 2020 after that. They were shut down and they reopened. Their board or the list of medical professionals who are on their webpage, none of them have hyperbaric medicine training. There is one physician on list who says that he's a member of the UHMS, not a fellow or accredited chamber operator or diving physician. Again, like I said, the operator was absent and there was no, there was no emergency response or SOP. Now we'll talk about Malta, and this is a very tragic incident which should not have occurred. There have been only 2 known cases in the history of hyperbaric treatment for divers where a conscious walking diver who walked into a chamber then died. One happened 40 years ago, about 40-50 years ago in Italy, and this is the second case. So Christoph, or Tato as he's affectionately known, was a very accomplished technical diver and instructor. He and a group, he was the one, they're a group of UK-based divers, and he had a club of 100 divers with them, and they used to come in for trips, go across the globe for trips, diving and teaching. Now this was a small group, it wasn't 100 people, there were about 12 people in this group, and they were diving SS Polynesia in Malta. One of the divers had an issue at depth and started to have an uncontrolled ascent. Tato went on and tried to help him and ascend him. Now during that ascent, they missed decompression. They surfaced, they missed all their decompression stops, and once they reached the surface, Tato asked for a chamber. The first things he asked for a chamber because as somebody who's that experienced, who's done enough dives, you know the first thing you want is a chamber. He went back in to try and do some in-water decompression. There are methods and procedures to do that, but they could not complete decompression for some reason, and they went back into the chamber. So I was able to get some information from various sources, including some of the divers, and they said it took them about an hour to get from the site to the chamber, breathing pure oxygen, which is not too bad if you think about a remote diving location. So one of the divers who came in was declared dead on arrival when he reached the hospital. Now, the second diver was recompressed. There were quite a few issues in this, and I'm going to highlight a little bit. We don't know what exactly happened because this is still a sub judice. Now, what did happen was at some point, the diver started feeling short of breath. It was attributed to the fact that his oxygen bibs was not giving him oxygen properly. Now, whether it was the right depth or the right treatment table being followed, we don't know yet. Again, I don't want to speculate on this. So when he developed shortness of breath, they made sure that the bibs were open. They got the bibs open. The bibs were not open in the first time. So then they started giving him pure oxygen through the bibs. Now, what happened thereafter is a slight cascade of events where the attendant who was left, as in the hyperbaric doctor in the chamber of the hospital in the chamber, decided to leave the patient and go off for whatever reason wherever he went. But they left somebody in as an attendant who was a trainee who was not qualified enough to run the chamber by themselves. So one of the things which came to light was that the dive was conducted to 60 meters. However, the initial treatment was conducted with the assumed depth of 50 meters. So that itself would have given them an incorrect decompression schedule. Even though they were on rebreathers, they still would have had a large enough number of decompression if they missed everything. Again, hyperbaric consultant left the hospital and ignored the calls from the trainee in the sense that I'm probably using the wrong terms. He took the calls from the trainee but ignored the information that was given to him when the trainee asked for help. The patient was recovering. At a certain point in time, one of the divers says that he responded with a thumbs up signal from inside the chamber when they were trying to figure out how he was doing. When I say one of the divers, as in one of the divers who was with the team. So what also happened was that if those of you who have dived and have done technical diving understand that when you're breathing a particular gas, if you're not on that gas and you switch to that gas late, you need to compensate for the missed time, right? If you're supposed to be on oxygen and you're breathing air, the partial pressure of gas that you're breathing in is incorrect. So therefore when you switch to oxygen or you switch to a higher mix, you need to compensate for that lost time. There was no compensation given for the lost time when he was on air and where he developed the shortness of breath because the bibs was not working. The trainee's phone call, again, like I said, was ignored. It was also misdiagnosed because at some point the patient started seizing, and the doc or the consultant diagnosed it as oxygen toxicity, whereas it was more likely to be decompression sickness. Now, there were documentation errors. We don't know exactly what treatment was done. I spoke to somebody earlier and they said that the medical report hasn't been released yet because it's still being processed judicially. Now, like I said earlier, this is the second known case of a diver going in, walking into the chamber, and then having an event. It's generally, and why we say it's the second known and why it's so bad, because it wouldn't happen. You would walk out of the chamber and then collapse, and that would be a problem. But if you walked into a chamber and you did the right treatment, as long as you had the right gases, you would probably not have such a bad outcome. So we've spoken a lot about different accidents, different types, aerospace, diving, hyperbaric fires, as well as poor hyperbaric treatment. We'll talk about accident analysis now. I'm going to just try and fix this. So human factors throughout, what did we see? Poor maintenance, equipment, bad training, negligence, overexertion, lots of different communication issues. Equipment standards. Now, there are laid down standards for equipment. We'll cover that in a little bit. Maintenance for the Florida chamber was not maintained at all. Training. Whether you do a course once and you expect your team to be proficient after 5 years of doing that course, unless you're doing it every day, I think that's just something which needs to be redone periodically. I'm sure you understand that, and from this litany of accidents that I've spoken about, there's quite a few which clearly indicate that there's negligence on these in these accidents. Communication in all cases, if you look at the communication in the NASA incident where it wasn't taken as clearly or wasn't maybe the gravity of the situation was, I'm using the word gravity when I'm talking about NASA, but it wasn't understood that well or it wasn't thought about. Or if you look at the fact that in Tato's incident, the communication between the trainee and the consultant wasn't good enough, or they didn't understand things, or helium being used in Byford Dolphin and that making a squeaky voice. Those of you all who've used helium would have loved playing around with it. In a number of situations, you would have realized that there's no standard operating procedure for these chambers, primarily because people were just winging it. And that goes again back to the first two slides we were talking about in terms of the indications, where the UHMS has a particular language of indications and the FDA has a separate one, which is again trying to make things easier for people to use it. Failure to act. In most cases, you had situations where the flammable material was not removed from the NASA chamber, and you had situations where the chamber operators left the location, or you had incorrect information being passed and no action being taken. Tampering, and here you see in the Florida case again, tampering of the data, tampering of the maintenance schedules, putting false stickers when no maintenance was done. Performance stress, when you look at the Byford Dolphin incident, with a 16-hour work schedule in deep saturation diving, maintaining bells and things like that, you need to have some amount of leeway for your teams and give them rest so that they get adequate, so that they can perform well. Lack of supervision, again, throughout some of the chambers, you found that there is either no trained specialist, or the trained specialist has left and inadequate or poor supervision exists. Obsolete SOPs, again, if you get a new chamber or you get new equipment, you need to have the right and fresh current SOPs. So, with all of this, we'll quickly move to a recommendation. The NFPA 99 or relevant European guidelines already exist. And what I would recommend is follow the recommendations, follow the guidelines, ensure proper training and credentialing. Now, even if you've got somebody who has spent a few hours running chambers, if they're not doing it the right way or the safe way, then get them trained. Make sure that, and this is not just chambers, this is anything that you're using, any equipment that you're using. If you've got somebody who says, we've been doing this for years, this manner, please think about making sure that they do it in the right way, in the right manner, and get them credentialed. So this is the pressure vessel for human occupation 1 standards, which is I'm not sure what this acronym is, but I think it's the American Society of Mechanical Engineers. So this is a safety protocol and the design protocol for the PVHO 1 standards. I will not go into it, but it means that you basically have a certain amount of time, annual servicing, certain amount of time left towards acrylic windows, glass windows, valves, and seals. Following established tables and treatment protocols, yes, I did show you all a goat, and yes, a lot of our tables were based on goats, but Over time, there has been a fair amount of human-related studies, and now we have both male and female divers. So we've got tables that are generalized across the board over time for divers. So the established protocols have known to be safe, which is why you've had only 2 incidents of a diver who has been well going into a chamber and then having a problem. So as always, not just in chamber operations, in any operations, stop and reassess whenever you have a doubt or whenever you hit a critical milestone. What we do when we are in a chamber, when you reach a particular depth, you stop, you assess the patient, and then you decide whether you're moving on or whether you're going up or changing the protocol. Make sure that your chambers and your team is accredited, because it's not only a liability issue, but also once you get an accreditation, it's like an audit for your procedures and your equipment. So these are my references. Anybody wants to take a shot? There's quite a bit of material here that's easily downloadable. It's mostly open source. And any questions?
No questions. Okay, thank you, Vish.
That's my information if anybody needs it, and that's it. Thank you.
This has been a presentation from the College of Remote and Offshore Medicine. If you would like to earn CPD credits for this podcast, you can join the Council of Members. Being a member of the college gives you free CPD credit, free access to our virtual field guide, and discounts on our e-learning courses. You can join the team on our college website at corom.edu.mt.